Hello, my viewers all over the world. Welcome again to Quadratic TV. I have another topic to teach. Today, we'll be looking at how to construct a quadratic equation from the given root. In this topic, you will not only learn how to solve quadratic equation, but after solving the quadratic equation, you are expected to get the answer. So whatever answer you get from the solution of quadratic equation is what will help you or what you use back to get back your quadratic equation. So from the root is the answer you get when you solve a quadratic equation. So you can still use that root to get back your quadratic equation. So let's quickly trash this. So this is a particular root of a particular quadratic equation, and you are required to, from this root, get back your quadratic equation. So let's start. I will do it in two ways. The first step is you introduce a variable and change their signs. Now this is minus, you change it to plus. This is plus, you change it to minus, and you equate to 0 in a bracket. So let's quickly do that. So here I will introduce my variable, which is x. This is minus 2, I will change it to plus 2. Group it. Here, the same thing, x. This is plus 5, I will change it to minus 5. Then I will say equals to 0. Having done this, the next thing I will do is to open up the brackets. So let me open up the bracket. I will use one of the brackets to open the other one. I will do that right away. This is going to be x, we'll open up x minus 5, and then plus 2, we'll open x minus 5, all equals to 0. So it is easier for me to do now. What I will do now is opening the bracket. So x will multiply x to give me x squared. This and this will give me minus 5x. Plus 2 and x will give me plus 2x. And plus 2 multiplying minus 5, I will have minus 10, all equals to 0. So at this point, I will now have to collect my like terms. Like terms are those ones that look exactly alike, and it is the two that's at the middle. So in a exam situation, you do not look at them and get confused. Just come here, pick the two that is exactly your like terms. And that brings me to the first one, x squared. Here, minus 5x plus 2x from the knowledge of my directed numbers. I don't need anybody to tell me that I will be having minus 3x left. Then I'll bring down the last digit, which is minus 10, all equals to 0. So this is my required quadratic equation. If you get this, since you already know quadratic equation, you can still solve back to get your root. So this is the root of this quadratic equation. So as you can see, I've been able to get the quadratic equation through the roots. So I have another example 2, where something looks like fraction. If you look at it, I have 1 over 3. Here I have 4. One fraction, one non-fraction. So if you come across this situation, well, what you will do is very simple. What you will do is to make both of them to look like fractions. That is to say, all over 1. I will do that right away. Remember the rules. Assigning a variable and changing their signs. So here, I will assign a variable x, which I like assigning, and the sign of this one will be plus 4. Then the same thing, x. Here is plus already, it will now be minus 1 over 3, all equals to 0. So I will use the first bracket to open the other. That is, x will start, it will open x minus 1 over 3, and the remaining one, which is what? Plus 4, is also going to open x minus 1 over 3, all equals to 0. At this point, I have to use what I have outside to open everything in the bracket. So let's do that immediately. X and x will give me x squared, while this and this will give me minus x over 3. Plus, this is 4 and this will give us plus 4x, plus 4 times this, I will have minus 4 over 3, all equals to 0. So at this point, if I can see something looks like fraction, the other one did not. That's exactly what I said there. So I will now make all of them to look alike by putting all over 1, all over 1. Having done this, I will go straight to look for their LCM. And the LCM is actually the highest value at their denominator. As you can see, the highest value there is 3. So 3 automatically is our LCM. So LCM, I notice LCM is equal to 3. So I can now start solving. 3 divided by 1 is going to give me 3 times x squared. So I'll have 3x squared. Then the next, 3 divided by 3 is 1 times minus x. I still have my minus x. 3 divided by 1 is 3 times 4x. I have my plus 12x. Now 3 divided by 3 is 1. 1 times minus 4, I have minus 4, all equals to 0. I have been able to put all of them in a linear equation. As you can see, it is now equation of a straight line. All I need to do now is to collect like terms, just like I did in the first example. So I'm going to collect like terms right away. The first one is powered. There's no other powered here. So I have to bring the first one the way it is. This is 3x squared. Now, here I have minus 1x plus 12x. That is to say, the knowledge of that directed numbers we discussed in our previous videos. So I'm paying you 1 when I have 12. That is to say, if I pay you your 1, I'll be having plus 11x. Then this has no one that looks like it. You say minus 4 equals to 0. At the end of the day, you have been able to solve or construct quadratic equation from the roots. So it simply takes us to this one, but in this one, I'm going to leave it for us to solve so we can discuss it in the next video. Bye.